In this set of slides, we look at life insurance and asset allocation decisions. In this section, we study another risk aspect of human capital, mortality risk. We first explain the rationale for examining the life insurance decision together with the asset allocation decision. We also provide a number of case studies in which we illustrate model allocations that depend on income, age, and tolerance for financial risk. So mortality risk is the family's loss of human capital in the unfortunate event of the investor's premature death. It's huge for many investors because human capital is their dominant asset. Life insurance is used to hedge against mortality risk, and the greater the value of human capital, the more life insurance is optimal. Term life insurance and human capital have a negative 100% correlation with each other. So life insurance is the perfect hedge for human capital in the event of death. If one pays off at the end of the year, then the other does not, and vice versa. Thus, the combination of the two provides great diversification to investors' total portfolio. So based on the 1-year renewable term policy, the premium for a 1-year renewable term policy is paid at the beginning of each year and protects the human capital of the insured for the duration of the year. We want to maximize overall utility in alive and dead states by choosing term life insurance plus 2 asset classes, stocks and bonds, or risky assets and safe assets. So as I said, we assume there's 2 asset classes. The investor can allocate financial wealth between a risk-free asset and a risky asset. Also, the investor can purchase a term life insurance contract that is renewable each period. The investor's objective is to maximize overall utility, which includes utility in the investor's live state and the investor's dead state, by choosing life insurance, which is the face value of a term life insurance policy, and making an asset allocation between the risk-free and risky assets. The optimization problem can be expressed as the equation up the top there. And what that says is maximize, and theta x is the amount of life insurance and the allocation to the risky asset, subject to the expected, and in square brackets, 1 minus d, where d is the relative strength of the utility bequest, times 1 minus qx, where qx is the subjective probabilities of death at the end of year x plus 1, conditional on being alive at age x, times the utility of being alive, times total wealth, which is financial wealth and human capital wealth, plus the relative strength of the utility bequest, times the subjective probability of death, times the utility of death, the dead state, times by the financial wealth, plus the amount of life insurance, and the brackets. So the utility of being alive and the utility of being dead are utility functions associated with the alive and dead states. So the life insurance model, the model shows that the human capital is the central factor. Correlation between income and risky asset returns plays an important role in both decisions. All else being equal, as the correlations between shocks to income and risky assets increases, the optimal allocation to risky assets decline, as does the optimal quantity of life insurance. In addition, a higher correlation with any given sub-index brings about a second result. That is, it reduces the demand for life insurance. The reason is that the higher the correlation, the higher the discount rate used to estimate human capital from future income. A higher discount rate implies a lower amount of human capital, thus less insurance demand. Second, the asset allocation decision affects well-being in both the live consumption state and the dead bequest state, whereas the life insurance decision affects primarily the bequest state. Bequest preference is arguably the most important factor, other than human capital, in evaluating life insurance demand. Investors who weight bequest as more important, i.e. they have a higher D, are likely to purchase more life insurance. The model also considers subjective survival probability, 1 minus QX. Investors with low subjective survival probability, those who believe they have a high mortality rate, will tend to buy more life insurance. The model implies that the more financial wealth one has, all else being equal, the less life insurance one demands. So we're going to look at a few case studies. For all 5 cases, we assume the investor can invest in 2 asset classes. We use the capital market assumptions previously provided. The female investor's preference towards a bequest is 1/4 of her preference toward consumption in the live state. She has no health issues. Her subjective survival probability is equal to the objective actuarial survival probability. Her real annual income is $50,000, expected to grow with inflation. The volatility of the growth rate is 5%, and she saves 10% per year. She expects a pension of $10,000 each year in today's dollars when she retires at age 65. Her current financial wealth is $50,000, and she's assumed to follow CRRA utility with a risk aversion coefficient of Y. Her financial portfolio is rebalanced and the term life insurance contract renewed annually. Okay, so let's look at case study 1, involving human capital, financial asset allocation, and life insurance demand over the lifetime. Now in this one we assume a CRRA or a Y of 4. The correlation between the investor's income and the market return of the risky asset is 0.2. For a given age, the amount of insurance this investor should purchase can be determined by her consumption/bequest preference, risk tolerance, and financial wealth. So you can see as time goes on here, as her age increases, her human capital decreases, as we know, and in direct proportion to that, the face value of her term life insurance also declines until age 55, and then it flattens out. Allocation to the risk-free asset is 0 up until around age 42, and then it increases. So that picture showed that human capital decreases as age rises, financial capital increased as she aged, the allocation to risky assets decreased as she ages, and demand for insurance decreased as she ages, because a decrease in human capital reduces the demand for insurance. Case study 2 is about the strength of the bequest motive. So assume that the investor is age 45 and has an accumulated financial wealth of $500,000. The investor has a CRRA coefficient of 4. If you can flick back to the graph, you can see that insurance demand increases as the bequest motive strengthens. There's almost no change in the proportional allocation to the risk-free asset at different strengths of the bequest motive. The asset allocation is primarily determined by risk tolerance, returns on the risk-free and risky assets, and human capital, and the bequest motive has a strong effect on insurance demand, but little effect on optimal asset allocation. So it is a misunderstanding that a person needs a large amounts of life insurance only when they face the greatest chance of death, i.e. in old age. To the contrary, the magnitude of loss of human capital at younger ages is far more important than the higher probability of death at older ages. Case study 3 shows the impact of risk tolerance. So this investor is age 45 and has an accumulated financial wealth of $500,000. The investor has a moderate bequest preference level of D equals 0.2. And as expected, the allocation to the risk-free asset increases with the investor's risk aversion level. So we have a risk aversion along the bottom. Allocation, which is the line to the risk-free asset, increases as the risk aversion increases. Optimal portfolio is 100% in stocks for risk aversion levels less than 2.5. The optimal amount of life insurance follows a similar pattern. Optimal insurance demand increases with risk aversion. For this investor with moderate risk aversion, a CRA coefficient of 4, and the human capital and financial assumptions that we have made, optimal insurance demand is about $290,000, which is roughly 6 times her current income of $50,000. This is at this level here. Therefore, conservative investors should invest more in risk-free assets and buy more life insurance than aggressive investors should. That's a summary. Allocation to risk-free assets increases with the investor's risk aversion level. The optimal portfolio is 100% in stocks for risk aversion levels less than 2.5. Optimal insurance demand increases with risk aversion, and conservative investors should invest more in risk-free assets and buy more life insurance than aggressive investors should. Case 4 is financial wealth. So this investor's age is 45, her risk preference and bequest preference are at moderate levels, with a CRA coefficient of 4 and a bequest level of 0.2. So the optimal allocation to the risk-free asset increases with initial wealth. Optimal insurance demand decreases with financial wealth. This result can be intuitively explained through the substitution effects of financial wealth and life insurance. In other words, with a large amount of wealth in hand, one has less demand for insurance because of the loss of human capital will have much less impact on the well-being of one's heirs. The optimal amount of life insurance decreases from more than $400,000 when the investor has little financial wealth to almost zero when the investor has $1.5 million in financial assets. In summary, for an investor whose human capital is less risky than the stock market, the more substantial the investor's financial assets are, the more conservative optimal asset allocation is, and the smaller life insurance demand is. It's a summary of those points. Case number 5, the correlation between wage growth rate and stock returns. The investor's age is 45 and she has a moderate risk preference and bequest preference. So this case evaluates the life insurance and asset allocation decisions for investors with a high correlation between the risky asset and the investor's income. This kind of correlation can happen when an investor's income is closely linked to the stock performance of the company where the investor works, or when the investor's compensation is highly influenced by the financial market. For example, the investor works in the financial industry. The optimal allocation becomes more conservative, the more to the risk-free asset, as income and stock market returns become more correlated, which is similar to the results described earlier. The optimal insurance demand decreases as the correlation increases. Life insurance is purchased to protect human capital for the family and loved ones. As the correlation between the risky asset and the income flow increases, the ex-ante value of human capital to the surviving family decreases. This lower valuation in human capital induces a lower demand for insurance. Also, less money spent on life insurance indirectly increases the amount of financial wealth the investor can invest, so the investor can invest more in risk-free assets to reduce the risk associated with their total wealth. As wage income and stock market returns become more correlated, optimal asset allocation becomes more conservative, and the demand for life insurance falls. So summary for that one is investors' income is closely linked to stock performance. The optimal allocation becomes more conservative as income and stock market returns become more correlated, and the optimal insurance demand decreases as the correlation increases.